Welcome to Matrix Motive, Elon Musk's Neuralink and the concept of a brain-computer interface, BCI, is certainly an exciting and intriguing topic. The idea of a second brain chip is still in its infancy, but it has the potential to revolutionize the way we interact with computers and even potentially treat certain medical conditions. But let's watch one of his recent interviews here.
So first, let's step back and big congrats on getting Neuralink implanted into a human. That's a historic step for Neuralink. And
Thanks. Yeah.
there's many more to come.
Yeah. And we just obviously have our second implant as well.
How did that go?
So far, so good. There looks like we've got, I think, on the order of 400 electrodes that are providing signals. So
Nice.
yeah.
How quickly do you think the number of human participants will scale?
It depends somewhat on the regulatory approval, the rate at which we get regulatory approvals. So we're hoping to do 10 by the end of this year, a total of 10. So 8 more.
And with each one, you're going to be learning a lot of lessons about the neurobiology of the brain, the everything, the whole chain of the Neuralink, the decoding, the signal processing, all that kind of stuff.
Yeah. Yeah, I think it's obviously going to get better with each one. I mean, I don't want to jinx it, but it seems to have gone extremely well with the second implant. So there's a lot of signal, a lot of electrodes. It's working very well.
What improvements do you think we'll see in Neuralink in the coming, let's get crazy, coming years?
I mean, in years, it's going to be gigantic because we'll increase the number of electrodes dramatically. We'll improve the signal processing. So, we even with only roughly, 10-15% of the electrodes working with Nolan, with our first patient, we were able to get to achieve a bits per second. That's twice the world record. So I think we'll start like vastly exceeding the world record by orders of magnitude in the years to come. So it's like getting to 100 bits per second, 1,000. Maybe if like 5 years from now, we might be at a megabit, like faster than any human could possibly communicate by typing or speaking.
Yeah, that BPS is an interesting metric to measure. There might be a big leap in the experience once you reach a certain level of BPS.
Yeah.
Like entire new ways of interacting with the computer might be unlocked.
And with humans.
With other humans.
Provided they have they want a Neuralink too.
Right.
Otherwise, they won't be able to absorb the signals fast enough.
Do you think they'll improve the quality of intellectual discourse?
Well, I think you could think of it, if you were to slow down communication, how do you feel about that? If you'd only talk at, let's say, 1/10 of normal speed, you'd be like, wow, that's agonizingly slow.
Yeah.
So now imagine you could communicate clearly at 10 or 100 or 1,000 times faster than normal.
Listen, I'm pretty sure nobody in their right mind listens to me at 1x. They listen at 2x. So I can only imagine what 10x would feel like, or I could actually understand it.
I usually default to 1.5x. You can do 2x, but actually, if I'm trying to go, if I'm listening to somebody in like sort of 15-20 minute segments to go to sleep, then I'll do it 1.5x.
Mm-hmm.
If I'm paying attention, I'll do 2x.
Right.
But actually, if you start actually listen to podcasts or sort of audiobooks or anything if you get used to doing it at 1.5, then 1 sounds painfully slow.
I'm still holding on to 1 because I'm afraid. I'm afraid of myself becoming bored with the reality, with the real world where everyone's speaking in 1x.
Well, it depends on the person. You can speak very fast. Like we can communicate very quickly, and also if you use a wide range of, if your vocabulary is larger, your effective bit rate is higher.
That's a good way to put it.
Yeah.
The effective bit rate. I mean, that is the question: is how much information is actually compressed in the low bit transfer of language.
Yeah, if there's a single word that is able to convey something that would normally require 10 simple words, then you've got maybe a 10x compression on your hands. And that's really like with memes. Memes are like data compression. It conveys a whole. You're simultaneously hit with a wide range of symbols that you can interpret, and it's you kind of get it faster than if it were words or a simple picture.
And of course, you're referring to memes broadly, like ideas.
Yeah, there's an entire idea structure that is like an idea template, and then you can add something to that idea template. But somebody has that pre-existing idea template in their head. So when you add that incremental bit of information, you're conveying much more than if you just said a few words. It's everything associated with that meme.
You think there'll be emergent leaps of capability as you scale the number of electrodes? Like there'll be a certain. Do you think there'll be like actual number where it just the human experience will be altered?
Yes.
What do you think that number might be? Whether electrodes or BPS? We of course don't know for sure, but is this 10,000, 100,000?
Yeah, I mean, certainly if you're anywhere at 10,000 bits per second, I mean, that's vastly faster than any human can communicate right now. If you think of what is the average bits per second of a human, it is less than 1 bit per second over the course of a day, because there are 86,400 seconds in a day, and you don't communicate 86,400 tokens in a day. Therefore, your bits per second is less than 1, averaged over 24 hours. It's quite slow. And now, even if you're communicating very quickly, and you're talking to somebody who understands what you're saying, because in order to communicate, you have to, at least to some degree, model the mind state of the person to whom you're speaking. Then take the concept you're trying to convey, compress that into a small number of syllables, speak them, and hope that the other person decompresses them into a conceptual structure that is as close to what you have in your mind as possible.
Yeah. I mean, there's a lot of signal loss there in that process.
Yeah. Very lossy compression and decompression. And a lot of what your neurons are doing is distilling the concepts down to a small number of symbols, of say syllables that I'm speaking, or keystrokes, whatever the case may be. So that's a lot of what your brain computation is doing. Now, there is an argument that that's actually a healthy thing to do or a helpful thing to do, because as you try to compress complex concepts, you're perhaps forced to distill what is most essential in those concepts, as opposed to just all the fluff. So in the process of compression, you distill things down to what matters the most, because you can only say a few things. So that is perhaps helpful. I think we'll probably get, if our data rate increases, it's highly probable that we'll become far more verbose. Just like your computer, when computers had my first computer had 8K of RAM, so you really thought about every byte. And, now you got computers with many gigabytes of RAM. So, if you want to do an iPhone app that just says hello world, it's probably, I don't know, several megabytes minimum, a bunch of fluff. But nonetheless, we still prefer to have the computer with the more memory and more compute. So the long-term aspiration of Neuralink is to improve the AI-human symbiosis by increasing the bandwidth of the communication.
Elon Musk is a true visionary, always pushing the boundaries of what's thought possible. With his Neuralink project, he's daring to imagine a future where humans and computers can seamlessly interact, and it's exciting to think about the potential benefits this could bring to humanity. Until next time, Matrix Motive.